Okay, so shockingly, right? Question 1, you also needed help. Calculation of the value. This one, make sure you key in exactly what you see into your calculator. Where the brackets are, the powers, make sure you get this correct. There's nothing for me to teach over here. Okay, for the calculation. Now the next part, where we have to correct our answer to one significant figure. Okay, so from your calculator, you will see that this gives us how much? 14 point something, is it? Oh, Ishan, what do you have? 14.586. Hey, you're supposed to give it to one SF. So for one SF, you identify the first SF, then this is the second SF. You circle the second SF, you decide whether you need to change the first SF or not. Since you are circling a 4, you do not need to change the first SF. And now this is rounded off to give us 10. Alright? Now next, arrange the numbers in ascending order. Well, pi, you can key in the calculator value. Find out the calculator value of pi. And that gives us 3.1415926. Okay? Put in a few more decimal places so that you can compare. I shouldn't be having to teach you this by now already. Now 3.14 with 2 dots recurring. This refers to 3.14141414, so on and so forth. The next number, 3.14 recurring, is 3.14444, so on and so forth. Now let's move on to 22 over 7. From our calculator, we get 3.142857. Now, ascending order, small to big. Which one looks like the smallest to you? 3.1415, 3.14. This terminates. It stops at 3.14. Is there any that is smaller than 3.14? No, there isn't. Everything is greater than 3.14. So our first number must be 3.14. Okay, so now we cancel that out. The next number, let's compare the third decimal place. 3.141, 3.141, 3.144. Oh, this is definitely out. Then 3.142 also out. That brings us to only the accurate value of pi, 3.14159 versus 3.141414. So we have compared the third DP already. They are all ones. Let's compare the fourth DP. This is 5 and this is 4. So that gives us 3.14 with 2 dots on top of the 1 and the 4. Now we're done with this. That brings us to pi already. And the next one will be 22 over 7, because the third decimal place is a 2 versus a 4 over here. So 22 over 7, and finally 3.14 recurring. Okay, any questions? Seriously, it's just comparing numbers only. Why do you all shock me by not being able to do this properly? Okay, now irrational numbers. Let me tidy this up. As long as you see dots above the numbers, they are rational. I don't care what the number is. As long as there's a dot up there, it is rational already. So we cannot put any of these highlighted numbers. They are rational. As long as there's a dot, it is rational. Can you remember that? Okay, so what are the irrational numbers? They are numbers that cannot be written as a fraction. Hello, this is obviously a fraction, right? So it's rational already lah. Okay, give me 22 over 7. 3.14 is rational also. It can be written as a fraction. The only irrational number over here is pi. Okay, next one. Explain if negative 250 is a term in the sequence. What is the sequence? The sequence looks like this. Look, Tn refers to term number n. So what does the sequence look like? If I say term number 1, I mean 7 minus 3 times of 1 minus 1 to give me 7. Term number 2 gives me 7 minus 3 times of 2 minus 1. Why 2? Because I put term 2 over here. Okay, and this gives me 7 minus 3, which is 4. What about if we continue, term number 3, 7 minus 3 times of 3 minus 1. So 7 minus 6, we get 1. So on and so forth. What is the sequence? The sequence is here, 7, followed by 4, followed by 1, and so on and so forth. The value is the sequence. Okay, arranging the values gives us the sequence. They are asking us whether negative 250 is a term in the sequence. They're not asking you whether term number 250 exists. No, they're not asking for that. They are asking you whether we can have a negative 250 over here. Is it possible? So your job is to answer the question. Is it possible to have a negative 250 where we have a term question mark equals to 7 minus 3 times of question mark minus 1, and it gives us negative 250. Is this possible? Negative 250. Okay. Now, obviously, we're not going to be putting question marks in our working. We're in secondary school already. For all the unknowns, we'll be using algebra. And what better letter to use than n? Because you are given Tn, the general term is 7 minus 3 times of n minus 1. And it will always be a term in a sequence. Always. Only if n is a positive whole number or positive integer. Right? Do you see that? There is no division in the formula. If there is no division, then okay, I take that back. Nothing about division. This is the pattern. This is the formula for the pattern. As long as you put in a whole number for the value of n, you are going to be resulting in another value, right? That is the sequence. So how can you be substituting n equals to negative 250 and then concluding anything? You cannot conclude anything. N cannot be a negative value. It cannot be a negative 250. But that's not the point. The point is whether this term exists. And then you should be writing this. 7 minus 3 times of n minus 1 is negative 250. You are supposed to check, but I want you to write it down first. That is an assumption. If it exists, let's see whether we can get the value of n. That is your thought process. If it exists, let me try and find out what is the value of n. Okay, so you go ahead and do that. And to my horror, you simplify the left hand side as 4 times of n minus 1. Oh, this one I really want to vomit blood. How can you have 7 minus 3 times of n minus 1 give you 4 times of n minus 1? They are different. You are supposed to expand. Negative 3 times n. Negative 3 times negative 1. So on the left hand side, we have 7 minus 3n plus 3. This is equals to negative 250. Continue. 7 plus 3 is 10. So to get rid of the 10, we must subtract 10 on both sides. So negative 3n equals to negative 260. I subtracted 10 on both sides. Now to find the value of n, I will need to divide by negative 3. So 260 divided by 3 gives me 86 and 2 over 3. So what does this imply? This implies that, hey, when your term number is 86 and 2 over 3, yeah, you do get negative 250. That's what it's trying to tell you. But is it possible for a term number to be 86 and 2 over 3? Can you have an index number of 86 and 2 over 3? Your index number, they are all whole numbers, alright? That is your position. We are searching for the position over here such that negative 250 is a value. And we found the position, but the position doesn't make sense. The position is not an integer. So we conclude this is not integer. So negative 250 does not exist in the pattern. Every time you see this type of question, all you need to do is to follow these steps. Step number 1. let formula equal term value. Okay, this is the formula it is given to you. And what is the value they want you to check? Negative 250. Let the formula be equal to term value. Next portion is step 2. Step 2. Solve for n, which you did. Solve for n already. The third step. Step 3. Conclude if n equal positive integer, then term is in sequence. If n is not positive integer, then the term is not in sequence. You need to know the logic on the left hand side. It is not so much about memorizing. As long as you understand the logic behind it, you can do this question and can explain properly already. Okay, next one. These are all recorded, they'll be uploaded. Okay, next question I'll go through is 5. Express this as a single fraction in lowest term. Back to basics. What do your primary school teachers say about fraction minus fraction? Denominator must be the same. That brings us to Sec 2 work now. We draw a parallel with, for example, 3 over 10 minus 2 over 5. What would you do? Denominator must be the same. Akila, is this a good idea? Is this a good idea? Why not? What about the denominator? I made it the same. Sorry, the other side. This is what I meant. Times 10 times 10. Okay, is this a good idea? I made the denominator the same. Is it a good idea? Not a good idea. Because the denominator then becomes very big, right? What would you all like the denominator to be? You like the denominator to be 10, not 50, 10. Because 5 is a factor of 10. You don't want to unnecessarily make the denominator very big. Because when you make it very big, you will still need to simplify it. What's worse when it comes to algebra? Yes, you can expand. You can take the whole thing, multiply by 3 minus x. Multiply by 3 minus x. Then on this side, you want to multiply 2x squared minus 5x minus 3. 2x squared minus 5x minus 3. You can. Mathematically, it's correct. But later on, you still need to simplify. Are you sure you want to do this? This is horrible, no? You're going to end up, wow, so many times of multiplication. And then you're going to have power 3. Look at the amount of work you have to do. So, we have to identify what is the factorized form for this. Can we factorize this? Turns out, yes, we can. We can factorize this. Okay? So, with your box, we're going to put in 2x squared, and we're going to put in negative 3 over here. So find the values for the factors for 2x squared. We have 2x and x. Standard. Nothing we can change over there. Okay? Now, we need the factors for 3, negative 3. If we forget about the negative sign, it is just going to be either 1, 3, or the other way around. 3, 1. Right? Okay, so let's try it first. Just now I started with 1, 3. So let's try that. 1 and 3. Okay? Now we multiply 1 times x, we get x. We multiply 2x times 3, we get 6x. Now we focus on whatever we have just found, 6x and x. Is it possible for us to generate a negative 5x? 6x and x. Is it possible to generate a negative 5x? Yes, it is. By introducing a negative sign to the 6x. When I introduce a negative sign to the 6x, I need to introduce a negative sign to the 3. So that 2x times negative 3 gives me negative 6x. By putting the negative sign for the 3, I also managed to get 1 times negative 3 equals to negative 3. Okay, so for now, I have successfully factorized our denominator on the left hand side. So I'm going to rewrite this now to give us 11 minus 5x in the denominator, 2x plus 1, and x minus 3. X minus 3. That is the left hand side already. Then we have to subtract 3 over 3 minus x. Now do you see common factor or almost common factor? Almost common factor? Here, x minus 3, 3 minus x. Almost the same. Now we bring back what we learned in Sec 1. In order to make the 3 minus x become x minus 3, not difficult. Just copy the left hand side first, 11 minus 5x, 2x plus 1, x minus 3. We're going to start changing 3 minus x to become x minus 3. The first step, we switch this sign. From minus become plus. I said switch because sometimes it is originally a plus, then you switch it to a minus. So you get a plus over here. That is the first change. The next change, numerator no change. The next change comes in the denominator. It becomes a switch around. 3 positive 3 becomes negative 3. I'll just put it over here. Negative x becomes a positive x. Now we have the same factor in the denominators. And it makes my job easier. All I need to do is multiply the fraction on the right with 2x plus 1. 2x plus 1. Now the denominators are the same already. Then we combine. 2x plus 1, x minus 3. Combine first, then expand and simplify. 11 minus 5x plus 3 times of 2x minus 1. That's a plus 1. And from here you go and simplify yourself. Expand and simplify. Get the answer. Almost every year they will test this. We want to see who are the ones who are going to multiply both denominators together. Then you end up with a power 3 and then you don't know what to do with that. Okay, remember my words, They will test this to see who are the ones who are going to end up with power 3. Because you multiply all the denominator together. Then later on your power becomes very big. Then you'll find that, wow, not enough space to do all your work. And then you don't know how to simplify. You don't know how to factorize after that. Okay, the next one I want to go through is question 6b. 2y squared minus 32 equals 0. Okay, this tells me that 2y squared must be 32. I add 32 to both sides. I add 32 to both sides. Another way of looking at it is, this 2y squared, you take away 32, you get 0. So that 2y squared must be 32 lah. You take away something from itself, then you get 0. Okay, so 2y squared is 32. Now we need to divide by 2. Y squared, 16. They didn't ask you to find y. They wanted y. They didn't want y squared. They wanted y. So to get rid of that square root, what is the opposite of a square root? What is the reverse of a square root? Ningwan, what is the reverse of a square root? Power what? Power 2. So 16 square? Square root. Okay. like this. You square root both sides, right? Are you the one introducing the square root? Look at the question. Is there a square root? No square root. Are you the one introducing the square root? Yes, you are. When you introduce the square root, you add in the plus minus sign. So how many values are there? You've got 4 or negative 4. There are 2 values. Check it yourself. When you take 4 square, you get 16. When you take negative 4 and you square it, you still get 16. So these are the 2 values. When you introduce the square root, put in the plus minus sign. Okay, now factorize 4 terms. When it is a 4-term factorizing, make sure you pair them up. You can pair them up this way. If there are common factors in the first 2 terms, generally, we are nice to you. Generally, you will find common factors in the first 2 terms. If you don't have, then you rearrange it yourself. Okay, so the common factor is y, m plus 1. That's the yellow color one. Okay, now let's look at the green color, the remaining 2 terms. We've got negative 3bm minus 3b. What is the common factor? I see a negative 3b as a common factor. Negative sign is a common factor, 3 is a common factor, b is a common factor. Negative 3bm divided by negative 3b, you get simply m. Negative 3b divided by negative 3b, you get 1. So this is what is in green. Next step, you've got y times of m minus 1. You take away 3b times of m plus 1. What are you left with? You are left with y minus 3b times of m plus 1. Must have brackets. What else? The next, I noticed some students they leave out this sign, the minus sign. Maybe wrong, because it is not multiplication. Okay, now for part B. Okay, just to recap, for factorization, we see, I don't want to talk about the sec 1 type of factorization, very simple. We see 3 terms with power 2. With a power 2, you draw the box. Okay? Factorization. When you see 4 terms, you pair them up. These are your factorization that you need to be very familiar with. Okay, now we come to this. Hey, what is this now? 3 terms. Power 2. Hey, the power 2 is over here, but that is not exactly the power 2 I'm referring to. These 3 terms still requires us to draw a box. But I didn't teach you how to factorize power 4. Then how? Let m squared equal to x. How about that? M squared equal to x. So what do we have from the original question? We get 2x squared minus 3x plus 1. I have converted the original question of 2m power 4 minus 3m squared plus 1 to become 2x squared minus 3x plus 1. And now we can factorize this very easily. Draw a box. So drawing the box, let me draw it over here. 2x squared again, 2x and x. I need a positive 1. If I need a positive 1, I'll put 1 over here to give me x and 2x. The question requires negative 3x. I only have positive 3x. I need negative. So what should I do? Put a negative sign over here. Put a negative sign over here. That gives me negative 3x already. But I can't just do that without editing anything else. To get a negative x, I need negative 1 times x. To get negative 2x, I need 2x times negative 1. And then for the final box, negative 1 times negative 1 gives me 1. So this is the factorized form. So this becomes 2x minus 1 and x minus 1. Now, from here, we change back. M squared was our x. Change it back. So we get 2, instead of x, we write m squared minus 1. Then we have m squared minus 1. And we're not done yet. Turns out m squared minus 1, we can still further factorize it. 2m squared minus 1, m plus 1, m minus 1. This is the factorized form. Okay, probably can go through one last question. Okay, now let's move on to the graph question, where you had to draw a graph, and hence, in part C, hence solve. Hence solve the simultaneous equation. Well, I am happy to see that some of you remember how to do either substitution or elimination. This question says hence. If it says hence, you have to use your solution from the previous part. What is the solution from the previous part? It is to plot. And this is the 1 mark question. You are supposed to see where the two lines intersect. Okay, I'm going to randomly draw a line. If this is the line that you have on your graph, the solution is found over here. This is your x value, and this is your y value. If this is what your graph looks like. If your graph looks like, for example, like this, then where is your solution? This. X value of 3 is your solution for x. The y value is 1 point something. I don't know what that is. You are supposed to find the point of intersection to do your simultaneous equation. Okay, 2160. 2160 from 2 to the power of what? Yishan, what do you have? Section B already. Then 3 power 3 and 5. 2 power 4, 3 power 3, 5. I want 2160 over x to be a perfect cube. So 2 power 4, 3 power 3, and 5 over something gives me a perfect cube. For a perfect cube, we need the powers. We need the powers of the prime factors to be multiples of 3. If you look at 2 power 4, obviously the power 4 is not a multiple of 3. We need to bring it down. Why down? Because we are dividing. We need this to become 2 power 3. What about 3 power 3? Oh, it is a perfect cube already. 3 power 3, no problem. What about 5? 5 has a power of 1. 5 power 1 is not a perfect cube. I need to bring the power down. Down to what? Down to 0. So this is what I expect as my perfect cube. How do I get there? I need to divide by 2 to bring the power from 4 to become power 3. I need to divide by 5 of power 1. I don't bother writing power 1. I need to divide by 10. X equals to 10. Okay? Now this is for part C. The other questions that I am going through will be 14, B and C, 15, 17, and 19. Are there any other questions that you want me to go through besides those that I just mentioned? Okay, if not, I'll be preparing a video, uploading it to Google Classroom. You go and watch it yourself.